Good morning, ninth grade. I hope you guys are doing well today. We're going to get into your notes video for this week because I have somewhere I have to be in a little bit, so I need to make sure I get your stuff uploaded before that has to happen. I hope you guys are doing well and miss you guys. If I would have known the last Thursday that I saw you guys was going to be the last Thursday, it would have been different. And so I miss you guys. I wish that I wasn't teaching to an empty classroom, but that you guys were here. So we're going to go over our notes for this week. I am going to give you a shorter notes video this week. The reason I'm giving it to you this week is because I want you to start on that test project that you all have. All right. You will have a longer notes video next week. So keep that in mind. If you're thinking, I'll put it off, I'll do it, I'll wait until the very last second, you are going to have more notes next week. So this week would be a good time to go ahead and get started on it, all right? So electric circuits. There are two types, closed and open, but first we're going to define electric circuit. An electric circuit is a path that an electric current follows, okay? This path, it can be circular, it can be square, it can be however the circuit is laid out is how the electricity will travel. Also, before I get too much further into this, the smart board is really acting up today. I've already had to change the slide color 3 different times in order to get something to show up. So if it freaks out in the middle of the video, I apologize in advance, okay? Now there are 3 parts of a simple electric circuit. The first, of course, would be the source of current. Okay, there has to be current coming from somewhere. Current doesn't just jump into a circuit and start running. It's got to come from somewhere. Then you have a set of conductors. These conductors are the devices that are allowing the electricity to flow through it, allowing the current to flow through. If you say flow through too quickly, it gets tongue-tied pretty quickly. And then you have the load. The load is the device that transforms the energy of the electric current into another useful form of energy, okay? So with a light switch, right? That is the source of current, okay? You flip it on. Then the current runs through to the light bulb, which is the conductor, okay? It's running through the wires to the light bulb. And then when it hits that light bulb is the load because it transforms the electricity into light for us to use. All right, a closed circuit. This is a circuit that contains a complete path for electrons to flow from the source of current through the load and then back to the source, okay? So it's a complete, it can be laid out in a shape, but it makes a complete circle from start to finish, okay? Again, remember, it can be laid out in any shape, but for sake of from start to finish, we're gonna go with the circle, okay? And then you have an open circuit. This is when a gap is made in the circuit and electrons cannot cross it and current flow ceases, okay? The best example of this is a light switch, okay? Closed versus open. When it is a closed circuit, okay, when you flip that switch on, okay, you have closed the circuit, all right? You have connected everything to allow the electricity to flow from point A to point B and back, all right? Now, when you flip that light switch off, you open the circuit, okay? So, up, you close the circuit, down, you open the circuit, you break the flow of electricity, and the light goes off, all right? The switch is the device that opens or closes a circuit. Again, light switch, perfect example of this. Short circuits. Short circuits, these occur if electricity have the opportunity to take a shortcut through a circuit and avoid the load, if they have a way to avoid the endpoint, basically, where it's going to be converted into some sort of useful form of energy. Not that electricity itself isn't useful. How do I want to say this? A form that you can easily use. Let's put it that way. If it can avoid the load and avoid that form that you can easily use, it's going to take it, okay? Electricity looks for the easy way out. So remember that current will always follow the path of least resistance. Like I said, it's going to look for the easy way out. So if it has the opportunity to short circuit It's going to. That's why there's so many things like in your house, there are circuit breakers and different things like that to avoid those short circuits. Actually, we're going to talk about them on this slide. My bad. All right, so devices for preventing short circuits and overloaded circuits. The first is a fuse. A fuse is a narrow strip of metal housed inside a protective insulated case. It's designed to have a slightly higher resistance than the rest of the circuit. If you've ever heard somebody say that's something they were using blue fuse, okay, that means that the safety device inside that particular object gave out, okay, it quit working. And then the circuit breaker is an automatic switch that opens the circuit when current flowing through it exceeds a predetermined amount. If it gets too much, the circuit breaker says, hey, this is not safe, shuts it down. It's typically when you lose electricity to something in the house, okay? Maybe you have too many devices plugged into one wall circuit, so then the circuit breaker goes, not okay, shuts it off, all right? Circuit arrangements, there are two types of circuit arrangements. We're going to talk about both of them, all right? The series circuit, this is the loads. This is when, the loads are arranged so that the electric current flows through each load one after another. And we're going to break that down for you. So the current has to pass through one load before moving on to another. So it's kind of like checkpoints for the current, okay? It has to hit each checkpoint before it can move on to the next one. The resistance of individual loads add to each other in this type of circuit. So the first load, let's say it was 5, the next load was 10, the next load is 20, okay? You add all those together, 5, 10, and 20, and you get 35. So the overall load of the entire circuit is 35, okay? It has to do with each stop. The amount of current remains the same in the circuit. So it doesn't matter how many times it stops, it doesn't matter how many loads it goes through, it's the amount of current stays the same. So if you're flowing through 5 volts of current, it stays 5 volts of current the whole time. And then the total voltage equals the sum of the load's individual voltages. And then we have parallel circuits. So you have series circuits and now parallel circuits. Parallel circuits, these are These are when loads are arranged in separate branches of the circuit and the current is divided among them. The current flows through all loads simultaneously, so it doesn't have to stop at one point before moving on to the next. It can flow freely through all the points at the same time. The resistance is reduced as more loads are added, so the more loads you put on, the less resistance it's going to face, the more easily it's going to be able to flow. And then the total current flowing through increases as more loads are added. So here, if you start with 5, you add more loads, you can go up 5, 10, 15, 20, so on and so forth. And then the voltages of all the branches are equal. And that's where we're going to stop for today. Like I said, short notes video for today. But that's because I want you guys to focus on your paper this week. I want you to be able to get things done this week because you're going to have more notes next week. So just keep that in mind when it comes to science class. All right, guys? I hope you guys are doing well. I'm praying for you, and I miss you.